Hello and welcome to Autumn Math. We're starting our unit on transformations. We're going to talk about translations, then we're going to talk about reflections, then we're going to talk about rotations, and then dilations. So this is the first part, so we're going to give a high-level overview of transformations. So a transformation is an operation that maps or moves the points of a geometric figure in a plane. Today we're going to talk about translations, then we're going to talk about reflections, rotations, and then dilations. So let's also consider a subcategory, and we're going to define each of these in just a moment. Let's talk about the first three. These are called isometries because there are transformations in which the size and shape of the figure remain the same. So iso, same, metric, measure. So reflections, translations, and rotations are the first three we're going to cover. Those are isometries. The last, dilation, because the size of the object changes, it is not considered an isometry. All right, so let's talk about reflections, and we'll come back to these each individually. Reflection in separate videos. Reflection is a flip of shape over a line of reflection. So here's a line of reflection. We have a flip of a figure, a triangle here of the line of reflection from a pre-image to the image. We also want to note that the line of reflection is the perpendicular bisector of all the segments that connect all of the original points, pre-image, and the reflected points, the image. And we'll get into this in much more detail if you want more detail in our next video on reflections. Translation. So again, translation is also an isometry. Translation is a slide or a shift of a figure. So all points of the figure move the same given XY amount. So I move the black box to the blue box, and that shift, that slide, is going to be considered a translation because all of the points for each figure move the same amount from black ending at blue. So the figure keeps its same size and shape. It's just shifting to a different location. Right. Rotation is a turning of all points in a figure by a given degree. The rotated figures rotate about an angle or a center of rotation. So you can see a certain degree here. So I have A here, and this becomes A primed. B becomes B primed. And then C becomes C primed. And then the last is dilation. Dilation is a shrinking or expanding of a figure by a given scale factor about a center of dilation. And again, we'll go into these more deeply for individual videos on transformations. All right, so today we're going to talk about translations. Our objectives are to understand the basic terminology of translations, right, rules for translations, and then identify coordinates of image and pre-image, given a pre-image, image, and a rule. All right, you'll find out what that means in a minute. Don't think too hard about that. We'll give you some examples. Okay, so translation is a slide or a shift of a figure. All points of the figure move a given XY amount, as we said. So here's the pre-image shifting to the image. So we're moving a certain unit X value every point. In this case, in the positive direction X. It can be in the negative direction, and we're moving to positive direction Y. And again, it can also be in a negative direction Y. All right, so we're going to skip that, and we're going to talk about translating 2 points from A to A primed, and we're going to talk about how we would write a rule. So we see that this point here goes from -2, -1, that's A, pre-image to the image, A primed. And so again, whenever you translate or transform a point or a figure, you're going to add to the points a prime value or an apostrophe. So I could translate yet again, and that would become A double primed. I could translate again A triple primed, so on and so forth. And we call these composition of isometries. And that's going to be or this could be a composition of translations. That's going to be a subject for another video. But I want to let you know there can be more than one transformation. So in this case, we're just handling one translation from A to A primed. For every translation or transformation, we add a primed or apostrophe value. From A to A primed, we're shifting 3 units to the right, so we say +3, and then 2 units up from -1 to 1, Y plus 2. So our command looks like this, in parentheses XY with an arrow, in parentheses X plus 3, comma Y plus 2. All right, so I want you to write a rule for this translation. I'm going to pause and then come back. All right, so the rule is, so X value stays the same from J to J primed. And then Y value is, we're subtracting 1 for each. So remember, every single point on the figure is translated the same amount. Okay, next one. I want you to write a rule for this translation. C to C prime to L prime, W to W prime. I'm going to pause here. Okay, so you can see that the translation, and all you have to do in this case is just take a look at 1 point. 1 to -4, so I'm subtracting 5. 2 to 3, I'm adding 1, so x minus 5, comma, y plus 1. All right, so drawing vectors. So vectors are an indication of a, can be an indication of a translation. And so we're going to write a rule for A, and now in this case it's going to be -2, 1. And I'm going to shift it to 1, -1. 1, -1. And we're going to write the rule here, x, y, with an arrow, x plus 3, y minus 2, and then we're going to shift that, or we're going to write the vector. So the vector can be anywhere in this vicinity, within a reasonable number of units from the image, the pre-image and the image. And so we draw the vector here. It doesn't have to connect these two, the image and the pre-image and the image. It just has to be the same length and the same direction of the line segment that's joining A to A primed. So drawing a vector, vectors must be exactly the same translation, identified as array arrow. So here's my arrow, which moves in this direction from A to A primed. As the endpoint of the ray is this starting point, or the pre-image, and then the tip of the arrow is going to be, so pre-image to the tip of the arrow to your image. Okay, so I want you to write a rule for this translation, then draw a vector. I'm going to pause here. All right, so we wrote a rule, xy becomes x plus 5, y plus 3. I'm going to draw the vector here in this direction. I'm moving 1, 2, 3, 4, 5 units to the right, 2, 3 units up, so x plus 5, y plus 3. All right, I want you to draw the translated image, give the command 1 unit left and 1 unit up, and then draw the vector. Okay, so 1 unit up and 1 unit left. So it becomes x minus 1, y plus 1, and here's my vector. So I want you to draw the image after it has been translated with the rule below, and then I want you to identify the coordinates. So here is the rule, and then I want you to translate, assuming each unit is 1, and then I want you to write the coordinates for the resulting values. Okay, so w becomes w prime 2, 0, e becomes e prime -2, -2, d becomes d prime 0, -4, and here's my vector indicating the translation. Right, so we're going to draw the pre-image and the image. So here is the pre-image, then here's the command. You're going to draw the image, write the rule, and draw the vector. I'm going to pause here. All right, so v becomes v primed. Our rule is x minus 2, y minus 5. So 2 units left, minus 2, 5 units down, minus 5. Here's my vector, v primed, h primed, w primed. I'm not providing you with the coordinates. You can figure that out on your own. Okay, now I want you to find the coordinates for the image after it has been translated, 3 units to the right and 7 units down, and then write a rule and draw the vector, and that will be it for today. Okay, so we're going to translate 3 units to the right and 7 units down, h primed, j primed, d primed, and y primed, and I said that I was going to find the coordinates, but I didn't, so let's take care of this. H prime becomes -2, -2. And j prime becomes -2, -3. And d prime becomes 2, -3. And y prime becomes 2, 1, 2, 3, 4, 2, -4. And then I've drawn the appropriate vector, 3 units to the right, 1, 2, 3, 7 units down, 1, 2, 3, 4, 6, 7. And that's it. That's it for translations. First subject for transformations in this edition of Ot Math. Come back and join us next time when we talk about reflections.